All right, welcome to 4.2. All right, talk to me just real quick here. Apportionment, are we okay? It's 4.1 went. We have this thing called the divisor, right, that we got to keep mindful of, right? And then we go back and we divide everything through that. And then once that's settled, then we figure out how much seats that we want to divide up, how many pieces we want to divide anything up. Okay, so real quick here, 4.2, 4.3 are going to be the division problems for our presidents. America's pretty young, so primarily it is for the is the House of Representatives. That's our issue, because the Senate already has 2 people per state, and that's set and fine dandy, right? The House of Representatives, now it deals with population. So how are we going to divide up population? So trivia question: how do we do it now? I don't know. Not the curious thing, right? You don't sit there like, how do we divide out House of Representatives? So Congress gets to decide every 10 years what they want to do. That's how they decide. So they either go with one of these 1, 2, 3, 4, 5 choices pretty much. And if they come up with a new rule, they'll come up with a new rule and say, hey, let's do it this way now. So every 10 years, actually this year, they are going to, because census is this year, and sometime this year they're going to divide which apportionment way they're going to do it. How fun is that? Okay, so let's jam. Hamilton's method. Let's go for it here. So Hamilton proposed a method in 1792. It is U.S. House of Representatives. So here's kind of how it gets. So every state gets at least their lower quota. So you kind of round down from the numbers, for sure. And then you figure out what is left over. And the person with the highest decimal left over gets the next seat. The next highest one goes from there. So let's jam with this one here. And once we see some numbers I think will be good. So let's go for it here. So standard quota, here it is. This is how many seats they should get. Again, we're not talking about the divisor, right? That was before already, right? So we're gonna go standard quota, and notice that everybody gets the lower one. Boom, 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 boom. Then this is the residue, they call it, over what's left over on the decimal. And so if you look across here, there's 246 seats filled in by the lower quota. That's fine. That means we have 4 more seats available. We look at the decimal part that's left over, and we pretty much just divvy out the other 4 seats based upon the decimal. Are we good? I think that's kind of fair, personally. Okay, so then you add 1 more to each of those, and you get yourself 250, and you're done. That is the Hamilton method. I am totally curious now. My next question is, what time period did they use which method? That's what I'm curious now. I'm gonna see if I can track that down somewhere. If you guys can find out, like, nothing to do on the weekend, like, oh, you know what? I wonder if I can Google that. All right, so it changes every 10 years. So then which 10 years did they use which one? What, America's 230 years old, so there should be like 23 different times that they changed or so. All right, so we good. At first glance, here's the not so good part maybe. Hamilton's method appears to be a good method for apportioning seats, but careful look hints shows a possible unfairness. What? That is no fun. So to compare the fates of state B and the residue of 0.72 and 0.70, those are pretty close. But B gets a surplus, E gets nothing, and then we're going to go from there. So let's go back up just real quickly here. Look at B. It had a 0.72 left over. E had a 0.7. It's like, well, you're the loser anyway, so who cares, right? Or we could say, okay, yeah, that's kind of fair now. Okay. Just out of curiosity, right? Is this would this be an issue or not? House of Representatives, sometimes things are so I guess in my mind I go back to say, okay, were there any bills or anything that was in the House of Representatives that were like 4 votes shy, right? Or better yet, it's more like when elections come around, right? You see the split in the House of Representatives, how many Democrats, how many Republicans, how many independents you have, right? And between that, if it's a pretty close margin, then 4 seats do matter quite a bit, right? If it's a widespread margin, like, if it's along party lines, you're not going to get as much. All right. Okay, and then also it kind of just says in your notes as well that maybe it actually, it's a little biased towards the bigger states. When you crunch the numbers, and you keep on crunching the numbers. Okay. So I'm going to skip the example, but okay, let's see if we can get just to homework or let's get to a problem that we have. This chapter here. There it is. Okay, we good? So get out your pens or pencils, whatever you need, your extra sheet of paper here. Let's try. This is number 14. So find the apportionment under Hamilton's method of the University Hospital nurses. The 5 units. So ECU, I know ICU. That's intensive care unit. ECU, anybody? Emergency care unit? That sounds about right. All right, anybody know what PU, MU, and SU stand for?
I think PU is
Pediatrics,
pediatrics.
Guess that too. The others, I don't know. I'm not sure. What else is you? Say again?
Monsters University.
Has to be something in the hospital here. Something in pediatrics, P for pediatrics, that makes sense.
BS for surgery.
Surgery unit, That's cool. Okay, I'm gonna think about MU. Word. Okay, so here it is. Let's see. Find the apportionment under Hamilton's method of the University of Nurses to the 5 units described in exercise 4. Okay, did I build this correctly here? Now that I want to make sure. Go back. Let me check. Check if exercise 4 had more numbers there. So we're not getting enough numbers here. Okay, so there are 250 nurses working in the 5 units, and they are apportioned to the units based upon the number of beds in each unit. So we have to get our standard divisor first before we even get to the other pieces here. So this one is the one that, let's see, there's 250 nurses working in 5 units. So talk to me. Let's see. It's been a while here, but do we know how to do how to set up the divisor for 4.1? Anybody?
It's like
I think we'll be good like that, yeah. So let's see. The standard quotas are calculated by exercise 4C. So see if we get the same numbers here. So we're going to add all these up real quick here. If you have a calculator here, 21 plus 19 plus 35, 30, and 25. What do we get as a total there? $130. See? Okay. Divide by what? 250. 0.52. than half. 1 second. Let me just make sure I'm correct here on it. Total population. Okay, coming in. Okay, yeah, sorry, I was multiplying, dividing in my head real quick here. So we're good, 0.52, is that what we have? Okay, so we're gonna go then underneath, if you wanna make this little chart, underneath it, then you get put standard quota, and then you can divide by this number, right? So it'd be 21 divided by 0.52. Is there more numbers than 0.52? No, it's exactly 0.52.
0.5.
Oh, sweet, okay. So 21, then 21 divided by 0.52 gets us what number? I'll take this chair here.
What section are we on?
We are in 4.2, just started. So I'm gonna put SQ, standard quota, then would be here. For each one of these pieces. And anybody give me some numbers here. So 21 divided by 0.52. 40.38, perfect. 19 divided by 0.52.
36.53.
Okay. So this one is the exercise problem. It's right after the finishing of 4.2. So we just talked about Hamilton's method. And I think as you go through this problem, you'll find out how to do it here. We just finished talking about it here. So 35 divided by 0.52. But it should not be in your notes. It should be, this is the new stuff that's usually not in your notes. 67.30. All right, pediatrics unit.
57.69.
Okay, 25 divided by point. I think we call it the surgery unit.
48.07.
Okay, cool. So Hamilton method, here we go. So everybody gets a lower quota, right? I'll just put LQ then for lower quota. And we'll see how many we have at the end. At this point, you also probably want to put little totals on the side as well, because that kind of helps, especially this one here. Okay, so everybody gets the lower, so you just round down all the time. This is 40, that's 36, that's 67, that's 57, that's 48. Can I get a total for what we have already so far? All right, can I get a second on that just to make sure? 148? 148, is that true? Or 248?
200.
Okay, okay. Just making sure. So are we good there? So we're just defining how to. So I got 2 more seats left. And so what we're gonna do, we call it the residue. At least, I'm not sure if it's still called the residue. It's just the leftovers from the decimal point, but let's even skip that part. I think we can kind of just do first and second already, right? So what's the nearest decimal to 1 from all the decimal parts? What do you guys say? Surplus. I think that's called a surplus. There you go. So are we okay with ECU is 0.39? That's 0.53, right, as the extra part. Are we good there with the decimal, extra decimal part? That's 0.30, that's 0.69, that's 0.07. So I guess we have 2 extras, is that right? We've got a surplus of 2 more seats, or 2 more nurses in this case. right? So we have to divvy out the last two nurses. And it's just going to go to the highest decimal part. So tell me if you guys agree. 0.67 is the highest decimal part. That's first place. And then next one is 0.53, right? There's your surplus. We're good? So everybody gets the rounded down version. Check how many seats are left. And we look at the decimal to figure out the rest. So final totals, here it is. See if we got it right here. Final totals of nurses. I got a 40, a 37, a 67, 58, and 48. And that should, if we checked it right, that should total 250. If we can just double check just to make sure.
So to know who gets the seats, we look at the decimal part?
Uh-huh.
Okay.
Yeah, we judge it based upon first, second, third. Okay, talk to me. Any questions on that?
How do you get the number that you divide?
Oh, perfect, yeah.
The number with?
Sure. So we have it, it's called SD, or standard divisor.
Mm-hmm.
It's the total from these numbers here.
Yeah.
Right, total divided by how many things you have to offer. So how many, in this case, you can say seats, right? How many nurses in this case? It's all that.
And
so
for this, how many was it?
250.
250.
Mm-hmm. It said in exercise 4 that there was 250 nurses that need to be split off between the departments.
Okay.
Cool. All right, got a couple of people writing it down. In this case, you probably want to get like an extra sheet of paper or something so that you have some room to write on.
Are we gonna always have to find the standard divisor?
I'm thinking yes.
Okay.
Let's see. I don't think we ever do that otherwise. Okay, are we good? All right, let's see what, I got some people still copying just a little bit here. So, as summary real quick here, you divide it by the standard divisor. You take the lower end, rounded down version of it. See how many seats are left. You look at the decimal leftovers. All right, are we good? Okay. All right, and then let's see if we got them. Let's see, go back and forth here. 40, 37. So 40, 37, 67. Yes. Yes. 58 and 48. We're good. We're awesome like that. Cool. Okay. Let's see, real quick here, just so let's skip that one. It's the same process. I don't want to be doing this. Is just percentages. That's all. So still same, right? We treat percentages same as numbers, right? There's no difference between how we treat them. Well, okay, maybe we'll have some time here. Want to try it just to try it here, just to make sure we got it. So go for it here. I'm going to read exercise 10 because I didn't know that we needed more information here. Exercise 10. It says, small island of Margarita. That's so cool. Margaritaville. Okay, there are 125 seats in the Margarita Congress. We good? So seats up on top here. 125. That's what we get. And you should recognize, let's see, we do 5, 9. I'm just making sure that's true. The exercises are all connected. So if you guys did already homework number 9, which is the one before 10, right? Notice that when I do in class, I do exercise number 18. It's connected to exercise 10. when you guys for homework you do number 17, it'll be connected to number 9, which you've done as well. We're good? So there's that little connection piece that you're going to go back to what you've done before. Okay, so question here is, when you add all these numbers up, do you get 100?
Yes.
Okay, so again, standard divisor, still the same thing. It's the total. And depending how many seats we have. So in this case, it's 100 divided by 125. Anybody got that number? 0.8, okay. Okay, and that's going to be our divisor. That's what we divide by. So then go ahead and divide that out. So I want to see it with decimals. So this is going to be 6.24 divided by 0.8.
So the seats is 125.
There's 125 seats,
Oh,
uh-huh.
Sorry, I wrote 225.
Ah, got it. Okay. Anybody?
Wait, I'm confused.
Oh yeah, sure. So in this one right here, it's
Oh.
going to be 6.25 divided by 0.8. That's what goes. Sorry, 6.24, bless
Oh,
you.
okay, I got you. What is it, 7.8?
Everybody okay with 7.8? Is that what you guys got? Just checking here. 7.8, exactly. Sweet. Okay, next one. 26.16 divided by 0.8. So each one of these.
32.7.
Okay. 28.48 divided by 0.8.
35.6.
Okay. And Matt, it's 35.6 exactly, right?
Yes.
Okay. All right. And last one.
48.9.
48.9. And it's called what? It's called, yeah. It's the City of Doritos. Love it. Okay, so this was our standard quota, SQ. Boom. So then we do our lower quota, LQ. Okay, I'll write it out here. Lower quota, so 7, 32, 35, 48. And then let's do a total over here. All right, what do we got here as the total? 122? 122, so we have 3 seats left that are not occupied yet. So now we're going to figure out what's first, second, and third. So the 3 highest decimal values. D gets 1, that's 0.9. And it looks like, I think I got A first, right? A with a 0.8. And then a 0.7, and now we're good. There it is. Okay, now that should be the in total. Added them all down. And these guys are called surplus in the book here. Okay, surplus. And then the way the book writes it is Hamilton apportionment. So that's 8, that's 33, that stays as a 35, and this one gets a 49 out of it, and I bet you it better add up to 125. Yep. Okay. All right, pretty cool there. I'll be good there. Not bad, not bad. Okay. So we said that the Hamilton one, it actually, if you do a lot of these problems here, you'll find out that it actually has a little bit of a bias towards the larger states. There's a little bit of that bias there. So we have Hamilton, president, 8 years. Should we do some fun stuff here? So, the reason why 8 years, the reason why 2 terms, because George Washington said that 8 years was enough. Thank you so much. I'm stepping down, right? So all the presidents until FDR followed suit as well. They only stayed on for two terms, and it was done, even though there was nothing in law to preclude them from ever doing that again. So FDR comes along and he stays on. Anybody know FDR? How many terms he went on?
3.5.
I want to say so. Yeah, 3. I know it was beyond 2. So 3.5 terms. Yeah, he did. He started his 4th term in office. So he did. Technically, it was 4 terms. Right. So then what happened was people on the other side of the aisle, they said never again. So they made it into a law that you can't. So he was a Democrat. Republicans said you can't do that again. So from here on out, you can only have 2 terms. And so it's kind of funny. In history, the only president that most people think they could have got a 3rd term was Ronald Reagan. And so a law that was enacted in the 1930s precluded the same party from having there. I thought it was kind of fun. Okay, are we good? Are we done with this one? Okay, so the next president comes along. And he says, hey, hold on. Oh, let's see if we got it right. We got it right here. This is, I got A's 8. Check your B's 33. City of Corona gets 35. And the City of Doritos gets 48. Okay, boom. So Jefferson comes along and says, oh, no. Still favoring the large states. You know, he was from Virginia, so I think he would have liked the Hamiltonian method here. But here's what we're going to do. We're going to do it a little bit different. And so proposed it in 1792. This was the Jefferson way of doing it. So he didn't like the whole concept of surplus seats and then adding more to it here. So he said, you should be able just to divide them all out, which would make sense for everything. Okay, so the way you eliminate surplus seats is by changing your divisor. Ooh. So, question, do we divide by divisor? Yes, but that divisor is going to be kind of funky right now. It also changes the quotas. So the idea is this. You use a smaller divisor, and we get the bigger quotas. If we hit it just right, we should be able to round the slightly bigger quotas down to the surplus seats are gone. Good? So you just you get it, and then you slowly start bringing things down. Okay. Let's look at an example. This one should be in your notes as well. So once again, we're going to apportion 250 seats in a certain Congress. Parador's Congress. All right. How's that for some funky name? The first 2 steps in the Hamiltonian are the same. You get the standard divisor and then round them down to the lower quotas. All right. So then you have 3 seats here. So how about this? Instead of using 50,000 as your divisor, how about if we bring it down to 49,500? Okay. That it's going to change the decimal points, right? It'll give you more in there here. So let's kind of see how it goes. So we round off the modified divisor down. So here it is. Population gets us, what is that? 12 million, 12.5 million. So we do this here. We add it up. We divide by 250 seats. We're good there? And 250 seats. And then we go and divide each one of these pieces here. And so if we do that, we get 248. So then we say, okay, what we're going to do is we're going to move our divisor down. So instead of 50,000, we're going to divide by 49,500. We're good? And then we do that. And then what we do is we always take the lower quota each time. And so as we modify, this is a little bit of a guess and check here. We good? But you do it until finally the lower quota is exactly what you want, which is 250. Okay. The divisor is not going to be very nice. We good? I just want to tell you that. All right. Okay. So just a few things here. So question of students comes up like, what? Seriously? We can't just take a random divisor like, oh yeah, I'm going to use this one, right? There's still a connection because you're still trying to get so many seats, right? So there's your connection. You can't just like pick randomly whatever, right? And so how do you pick the modified quota? You can't, and that's why on the homework, you may get stuck. You may go a little bit too low. Then you have to adjust it up. Notice it went from 50,000 to 49,500, right? We went 500 down, 500 lower, right? That's a big jump, right? But it could be that you went down by 200, and then you're like, oh no, that's still too much. Okay, I'm going to go down by another 200. Like, shucks, that's still too much. I'm going to go down by another 100. So this is one of those where you're going to have to kind of go back and forth to see what one's going to work the best, okay? Does that make sense to you guys, right? You might do a lot of divisions. Hopefully not too much here. All right, so let's go for it here. Oof, that's a little small print there. Let's see how much time we have. Okay, I think we can probably do this one here. This will be the one that we'll use as far as what we need here. So the Republic of Galatia, I think Galatia is divided to 4 provinces: Annalyn, Brock, Conwyn, and Drundel. Whoa, that's so fun. Galatia uses Jeffersonian's method to apportion the 50 seats in the House of Representatives among the 4 provinces. And so let's go one by one here. Show the population of the 4 provinces in millions after the most recent census. All right, let's go for it here. So it's kind of nice because it kind of lays out those things for you already. And just to save time here, let's skip out on this one. We'll go to that one, and there's a reason why, right? Because eventually your divisor is 500,000. Let's see. Let me just make sure that that's the way I want to do it here. Let's see if it will give me what I want here. I'll wait on that here. So you guys tell me your standard divisor first, and then the standard quotas. And let me look up here just real quick here, see if I find what I'm looking for. Boom. All right, so SD. What's my SD? So 50 seats, right? The total population in millions, right? So this is not, I have to convert it to millions here. So 5.9 plus 7.8, 6.1, 6.9, what do we get? 26.7. We have 50 seats. So what does that look like? Okay, so you know what they do? They actually convert it to millions, that's why. So boom, they do it like this. That's why you see these big, large numbers here, because they kept them in terms of millions. Divide by 50, so what do we have here? So 534,000, is that right? Okay, so real quick here, 534,000 is it. So this is still, we're working with A, right? So A, B, C, and D. Are we good there? Kind of looking for time to make sure we got it. So 5 point. I think you have to convert these into millions as well at this point. Pretty sure because you're not going to divide by something. But so this is going to be 5,900. That's 1,000, right? So still 0, 0, 0. Are we good there? Because you only have 50 seats, right? You're going to kind of divide 50 seats into pieces here. So anybody with 5,900,000 divided by 5,34,000.
11.04.
I go with that. And right on as well. Okay, we're good there. So this would be 7,800,000, divided by for Brock. All right, let me stop real quick here. Are you guys getting the answers on your calculator or phone?
I got something different.
Okay, that's what I want to make sure that we're all together here. So if you got it, keep on going. If you don't, let it come around. Okay, so what you punched in.
I punched in.
Good. So we put in 5. To get this number here, right? Yep. So we're gonna take this guy in millions.
Oh.
So you're gonna take 5,900,000, convert it to millions, then divide it by this number. Just to see you do that, just to make sure. Go from there. Good. It'll be what, 534? 100,000. You're almost there. So 5,900,000 divided by perfect. There it is. So this one. All right. What do we get for the other ones? For B.
14.60.
40.60. Okay.
11.42. And 12.92.
12.92 is pretty good by me. Okay. So then we have, let's see, that's A. So determine the seats portion of each province is given its lower quota. So B. B would be here now. The lower quota would be then 11, 14, 11, and 12, right? That would be your lower quota. Oh, okay. So B is not saying which. So how many seats would be given if each person got it? So 11 plus 14 plus 11 plus 12. What would that be? 48. So if everybody got their lower quota, we would get 48 seats. So there's 2 seats that are still up for grabs, right? Okay, so here's the fun part now. Not so fun part. we're going to have to, let's see, how should we do this here? Since we have extra seats left over, we have a surplus, right? So what we want to do is we want to decrease, right, our divisor a little bit. We want to make it smaller so that we have a little bit more seats there. So I'm going to go like this here. I'm going to scratch 3. Bless you. I'll just say for D, it's not going to work. No, hold on, let's see. For D. Yeah, let's do this. C, I'll give you the numbers here. For C, it's not going to work because what happens is you get 51 out of that. So it's kind of like too low. Does that make sense? For D, let me erase this. Or she, well, let's see. We got a couple of minutes left. Let's do the numbers here for this one here. So we want to hit 50. That's what we want to do. We want to hit 50 using a lower quota. So for C, we are going to use 500,000 straight. We're good? As your divisor. So can we look at, again, it's going to be 5900000, right? But divide that by 500,000. $11.8, okay, cool. And this one's going to be, again, it's going to be 7,7800,000, right, to give you that millions. We're good? Okay. $15.6, okay, no problem. We'll just keep on going here. If we can, let's do this here. Ashley, can you do C for me? 6.1 million divided by 500,000. Angel, can you do D for me? So 6.9 million divided by 500,000.
So are you reducing or whatever it is to the divisor so that it's like even? I don't know how to explain.
So yeah, so we're still doing lower quotas all the time, right?
Mm-hmm.
We're still doing that. That's part of the process. Okay. So we are going to lower our divisor. So we start off here and we're looking at 48, right? Mm-hmm. So because we have a surplus, that means there's not enough, our divisor in a sense is too big because it doesn't allow us the number of seats that we want.
Oh.
So our divisor needs to get smaller and smaller. We just found out, we're going to find out in just a bit here. What'd you guys get for C or D?
13.
For D? 13.8 for D?
12.
Okay, so let's see what happens for C with the remaining P's. So this is going to be 11, right? Because we're just reducing down, right? And we should get this right here. So as you do this, you find out you have 51. So using 500,000 is actually too small of a divisor. It gives you too many seats, right? So as you do it, I'll give you the next one here just so we know it. So for D, because this is just practice runs for us anyways. For D, what happens for D? If you divide by 530,000, you only get 49 seats. Means you're getting close. We good?
So every
yeah, good.
Like every 10,000 is like one. That's what I was thinking.
Kinda ish, yeah. That's what it turns out to be. So when we do D is E. When you do E, so this gives us 49, not enough. When we divide by 520, it gives us 50. And we're like, yes, we're done. Okay, just so you know, if you did F and you divided everything by 510,000, you still also get 50. Are we good? So it's not like this one's going to be like perfect, like that's the only number that works. If you use something close to it, you'll find out. that one as well. Okay, we're good there?
So all we have to do is change the divisor to get the number of seats that we want,
Mm-hmm.
and then that's it?
Yeah.
Okay.
You might have to do a little bit of work just like this to
Yeah.
get it.
Okay.
So 534 is where we started. 534,000 we start. We say, oh shucks, we only got 48 seats. So the divisor is too big because it's not giving enough seats. Let's lower it. If you get a situation where you get 48 seats and you want 50, then you're going to go higher than divisor, right? Then you're going to go 540, 550, right? Maybe 560 to get that number just right. Okay, are we good? Does that make sense to you guys? Okay. I figured we can spend extra time on this one because this one's going to be the one that gets you going with that. Okay. So real quick here, we finished up lecture for 243.